Okay, so we are on page 87, and this is another Explore activity. And basically what this does is on the left-hand side of this table, they give you a bunch of division problems. They give you the answer. You're not solving it. They just give you answers. And on the right, they give you a multiplication problem that looks suspiciously similar. And then what they want us to do is solve. We're going to do that right here. So we'll use what we learned in lesson 4.1 about multiplication, and we'll get answers, and then we'll compare our answers here to what we did here. If you want to try that on your own, that'd be fine. If you want help from me, that's fine too. We'll start with A, and then we'll answer some questions about it. So question A reads, well, let's read the title actually. Using reciprocals to find equivalent values. Question A reads, complete the table below. So like I said, we're going to do all these first. So I'll use the white space over here, and I'll do 6/7 times 7/2. And what do I get? Well, I'm going to simplify a little bit first. My 7 and my 7 would both simplify. They share a factor of 7, so I divide and get 1 and 1. And then 2 and 6. 2 goes into 6 3 times, and 2 goes into itself once. So I've got 3 times 1 is 3, over 1 times 1 is 1. 3 over 1 is equal to 3. So this answer right here is 3. And the kind of thing we should notice is that this answer is 3 and this answer is 3. We'll come back to that later though. Nope, 3 doesn't get erased. Alright, so the next one is 5/8 times 8/3. And once again, before I multiply, I look for things that simplify. 8 goes into itself once, 8 goes into itself once. 5 and 3 don't simplify, so I can just multiply. 5 times 1 is 5. And 1 times 3 is 3, and you get 5/3. And they don't necessarily care if we switch it over to an it is an improper fraction. They don't care if we switch it over to a mixed number, because check this one out. This answer is 5/3, and this answer is 5/3. Interesting. All right, let's check out the next one. 1/6 times 6/5. And my 6's simplify. 6 goes in itself once, 6 goes in itself once. And I've got 1 times 1 is 1, and 1 times 5 is 5. So I've got 1/5. And my last one is 1/4 times 3 over 1. And nothing simplifies, so I just multiply my numerators and denominators. I get 1 times 3 is 3, and 4 times 1 is 4. It's 3/4. And are you noticing what they're trying to get you to notice here? Which is that this fraction and this fraction are the same, and this one and this is the same. All my answers are the same. Now, did you notice the problem? And that's, if you didn't notice the problem, that's okay, but that's what we're about to notice here. That's what these questions are asking. Question B says, I'm going to make a little bit of space here real quick. I'll put those answers back when it's time. Question B says, how does each multiplication problem compare to its corresponding division problem? So let's look at the multiplication problems. Look at the left. 6/7, 6/7, that's the same. 5/8, 5/8, that's the same. 1/6, 1/6, that's the same. 1/4, 1/4, that's the same. So I'm going to start my answer with the first fractions are the same. Now, are the second fractions the same? Well, let's go ahead and look. I've got 2/7 and 7/2. What do we call those? What do we call those? 2/7 and 7/2. I've got 3/8, 8/3. 5/6, 6/5. 1/3, 3/1. What do we call those? There's a word for that. The first fractions are the same, and the second fractions are reciprocals of each other. That's really all question B was asking. They wanted you to notice that the first fractions are the same and the second fractions are reciprocals of each other. Okay, I am going to need this image to answer the questions at the bottom of the page, so I'm going to take a picture of it. Go ahead and make that a little bit smaller. And I'm going to move the page up, and we're on question C, and then a reflect. I don't think I need this anymore. Question C says, how does the answer to each multiplication problem compare to the answer of the corresponding division problem? Well, do you remember our answers? This answer was 3. This answer was 5/3. This answer was 1/5, and this answer was 3/4. All the answers are the same. All of the answers are the same. Should have been able to notice that without my help. All right, cool. All right, so there's a couple of reflects at the bottom of the page, and the first one's make a conjecture. That's like a summary. We need to make some kind of summary. What are we learning here? 8 says, make a conjecture. Use the pattern in the table to make a conjecture about how you can use multiplication to divide one fraction by another. So do you understand what that's saying? Can you use multiplication to divide? All of these problems on this column, I'm going to switch to green. All of these problems on this problem are division, and yet all of these problems on this column are the same answer. I got 3, I got 5/3, I got 1/5, and I got 3/4. And so what we are trying to get you to summarize here is that you can, I'm going to write, instead of dividing fractions, you can multiply the first fraction by the, starts with an R, reciprocal of the second fraction. Now, when we start practicing this, we're going to remind you about 1,000,000 times that we only do the reciprocal of the second fraction. We never do the reciprocal of the first fraction, and we kind of already pointed that out. Do you remember how we pointed out earlier that all the first fractions are the same? We never mess with that. It's only the second fraction in which we use the reciprocal. All right, question 9 asks you to make up your own. I'm happy to help you with that. I've got such a mess on this page right here, but I think I can move it. There we go. We're good now. Number 9 says, write a division problem and a corresponding multiplication problem like those in the table. Assuming your conjecture in 8 is correct, what is the answer to your division problem? I kind of want to go back to that page, that problem from page 85. We could do both, in fact. At the bottom of page 85, we wrote 2 division problems, and I'll review with you what they were. You could actually go back and look if you wanted to. But we wrote 2 division problems at the bottom. I'm even going to write that from page 85. From page 85, we wrote 2 division problems. One was 3/4 divided by 1/8, and we got 6. Now that doesn't look like it should be 6, but I can show you easily how it becomes 6 when we use the multiplication method. So what I'm going to do is I'm going to put kind of a slash. And now what I'm going to do is I'm going to do exactly what I tried to teach you a few minutes ago. We take our first fraction, 3/4, and we leave it. And we take our second fraction, 1/8, and we find its reciprocal. The reciprocal of 1/8 is 8/1. And go back up to what we just wrote right here. This is important. Instead of dividing fractions, you can multiply the first fraction by the reciprocal of the second fraction. So what I did here, notice, I had 3/4, I left it at 3/4, and then I took 1/8 and I did the reciprocal, 8/1, but it's multiplication now. So now this doesn't necessarily look like 6, but watch how it's 6. 3 times 8 is 24. 4 times 1 is 4. And 24 divided by 4 is 6. I hope you think that's as cool as I do. The answer is 6. And the answer is supposed to be 6 because we know from earlier, we know from page 85 that 3/4 divided by 1/8 is 6. But we didn't at this time when we did this especially, we solved this just using a picture. We didn't know how to divide fractions. And in fact, we still don't. But what we do is instead of dividing, we multiply the fraction by the reciprocal. I want to do one more here because there's another one on that same page. So I'm going to just clear everything. It's still from page 85. The other problem we wrote down from page 85 was 1/2 divided by 5 is equal to 10. Nope, it was equal to 1/10. I'm sorry. So I'm going to do the same thing I just highlighted here. Instead of dividing fractions, you can multiply the first fraction by the reciprocal of the second fraction. So the first fraction is 1/2, and instead of divide, I'm going to multiply. And instead of 5, I'm going to use its reciprocal. Do you remember that the reciprocal of 5, I'm going to come right over here, the reciprocal of 5 is 1/5? Those are reciprocals. That's the reciprocal right there. So the reciprocal of 5 is 1/5. And 1 times 1 is equal to 1, and 2 times 5 is equal to 10. And notice we get the same answer here as we do here. So that's proof that this method works. Number 8 right here, this is like the most important thing you're going to learn. Not all year, but it's the most important thing you're going to learn about dividing fractions. So make sure that you understand this concept, and maybe even watch this video a second time if you need to. Okay, good job. We're done with page 87.